In the last few lectures, what we were doing is we were looking at gas mixtures and properties of gas mixtures. What we're now going to do is we're going to move into a different form of gas mixture, and that is where one of the components of our gas mixture is a vapor. And consequently, if it's a vapor, that means that it can start going through a phase change, and so it changes the dynamics of the process a little bit. But what we're looking at now will be gas vapor mixtures. And a common application of this is air conditioning. This is an area that many mechanical engineers work in and contribute, and it helps give us a more comfortable existence in our buildings, given that we have controlled environment. So what we've looked at thus far, we've looked at mixtures of gases. And when we did that, we looked at mass fractions, mole fractions, PVT behavior, as well as properties such as internal energy, enthalpy, and entropy. However, when we were doing this, all of the components of our gas mixture remained in the gas phase. So we're now going to look at the situation where one of our components can go through a phase change. And I mentioned that an important application of that is the mixture of dry air and water vapor, and that pertains to heating, ventilation, and air conditioning systems. So air conditioning is one of the applications. Another one that we won't particular or specifically look at in this course, however it is important, is atmospheric sciences. And so processes such as cloud formation, short and long wave radiation or radiative flux coming from the sun and then energy being radiated back into space. That all kind of couples together with climate change. So when we look at global climate change, one of the big uncertainties is the contribution of water vapor in terms of the modeling efforts, and the place would be the contribution that water vapor would make, and consequently this is quite an active area, and it's an important area for people doing atmospheric science studies. We won't be looking at that in this course. What we'll be sticking with mainly is dealing with processes involving air conditioning, which is typically where mechanical engineers would contribute in this area. But as we're doing this, what we will be doing is we'll be considering air to consist of two parts. One part is dry air. And so this is typically air as we usually think of it. So typically we think of air as being mainly nitrogen and oxygen and then small amounts of other gases. However, when we talk about dry air, we are implying that there is no water in the air. Atmospheric air, on the other hand, which is what we deal with when we're doing heating, ventilation, and air conditioning, it is a mixture of dry air and water vapor. So what we're going to be doing is we're going to be taking a look at how to handle problems. In particular, we'll be looking at how to apply the first law and perhaps entropy generation, but mainly the first law in heating, ventilation, and air conditioning applications. And in order to get there, we need to come up with the equations that enable us to determine things such as enthalpy and other properties of the air that consists of dry air and water vapor. So that's where we're going to be going in this lecture, actually in the next couple of lectures.